Okay, we started our discussion on Java yesterday. We said that Java was originally designed for consumer electronic devices where you actually don't know the operating system, the CPU architecture, and etc. So they came up with this idea. They said that we are going to compile the program once, and as long as there is a Java virtual machine on the target platform, it's going to run everywhere. Okay, so compile once, run everywhere kind of approach. Later, they kind of gave up on this idea, and they started using Java for large-scale enterprise applications. Okay, like the government institutions, big banks, and the corporations, and that kind of stuff. Also, our Android phones are, as you know, programmed using Java. This was our workflow for the Java programs. You edit your program, you compile it. This one produces the bytecode, okay, bytecode or .class file. This file includes the executable bytecode, but execution is done through this Java virtual machine. Okay, Java virtual machine is, as the name implies, is not a physical machine. It's a virtual machine. It's a piece of software. It takes this .class file after it is loaded and verified, and it runs it instruction by instruction. So Java bytecodes are not really machine instructions. They are virtual machine instructions. Since they are virtual machines, you can, if you like, you can change your virtual machine without relying on the hardware, if you like. That's why we have 18 different versions of Java virtual machines. Okay, that's what we said yesterday, and this was our first example Java program. And we said that the name of the file and the public class has to be the same. In a single file, you may have more than one Java class, but if one of them is a public class, then it has to be the same as the file name. The others could be either private or no name, and we are going to talk about them later. And I have a main method inside this class. It's a public static void main. It is public as expected because we like it to be called outside of this class. It is static because it doesn't need any data fields inside this class. Also, I like to run this method without instantiating this class at all, and it doesn't return anything. It takes some parameters, and we will talk about those parameters maybe today. Okay, as a single executable line, it has a print line statement. It's like printf, but it only prints a string, and after the string puts a \n. Okay, out is kind of cout object of C++. System is we'll talk about the packages later. I think we started talking about them yesterday. System is one of the packages. Okay, and we talked about this addition. Okay, this one uses Java util scanner. This is very much like using stdcin kind of declaration. Okay, as we said yesterday, there are no include files in Java. So to be able to use some library classes, library functionality, you import them. You don't include them. Also, there is no, as you saw, there is no linking process in Java. Okay. So these are the things. Addition, it uses a scanner object. As we said, this is the only way for most classes. This is the only way to make a new object. Okay, new scanner, only way to make an object. And since this makes the object on the heap, you need to put a pointer, you need to hold a pointer to point to it. This is a pointer declaration. or in Java we call it reference declaration. Scanner input, new scanner. Okay, so that's the main idea. These are three integers. These are okay. How many variables we have? We have 1, 2, 3, 4. These 4 are created on the stack. 1, 2, 3, 4 on the stack. Okay, and this one is on the heap. Okay, this one is on the heap. Since these are on the stack, they will be deleted automatically when the scope runs out. Okay, when I hit this point, this one will die, this one will die, and will die. When this one dies, this one won't have any pointers, any references pointing to it. So its reference count will drop to 0 and it will die too. Okay, that's how it happens. So important to know the life durations of these objects. Okay, good. We talked about this print and numbers and etc. I think we looked at the documentation of the scanner class, right? So you compile it and you run it. This is what you get. Okay, arithmetic operations, we said that they are almost the same. Class definitions are almost the same, but not exactly. Okay, let's go back to this. This is my favorite C++ class, right? And this is my favorite, well, this is not favorite Java class, but one of the favorite Java classes. My Java favorite class is more complicated than this one. But this is almost the same thing as that one. Okay, Java class. I don't put a semicolon in there because Java classes are defined this way. So I told you that this is one of the biggest differences between Java and C++. You might say that it's a simple syntactic difference. No, it is not. Because I could say this, right? What is the meaning of this? I am making a class, I am declaring a class, okay? I am defining a class which doesn't give any data members or functions, but I know that default constructor, copy constructor, default assignment operator, destructor, move assignment, move constructor, they are all defined for this class, right? So A has all of them. I know that, right? Okay? That's the definition. I can declare my objects with the class definition. Because in C++, there are two ways to make objects. One is through this declaration, class A object like this. The other one is the new operator, right? In Java, you can't put a object name here, right? You can't put it in there because it is not an object name if you put it in there. That's why, since you are not allowed to do that, there is no semicolon. Okay? There is no semicolon. In Java, you would say, maybe I should put it in there. Okay. So I can say a object and JC Java class. Okay, this is an object, this is a reference, right? This is an object and this is a reference. There is no corresponding statement in Java for this one. This is Java. This is C++. Okay? When you write something like this in Java, it means it's a reference. It is not, there is no constructor called. To call the constructor in Java, you need to do this. New JC, and whatever the parameters are, okay? Whatever the parameters are. And I can do the same thing in C++. You will say APTR new A, right? Okay? So that's why I keep saying that this is an important difference between C++ and Java. Okay, any questions on this? Okay, why did they make that decision? I mean, no objects are made outside of a new operator. Well, they have their reasons. Well, one of them is, okay, keep everything dynamic. Okay, that would be more efficient. Don't occupy any stack space. Stack space is only for small objects only, for declaring integers and that kind of stuff. That's one thing. Well, when you do that, using new and using delete is going to be a problem, and they say that don't worry about it. I will handle the delete myself. You just make new objects. Okay, whenever their count drops to 0, then I will delete them automatically. That's what they say. Good. So we talked about those, and when we say class definitions are very similar to C++, but they are not exactly the same. But the access modifiers are the same. In Java, we don't have functions, we have methods. Since we don't have global functions, we don't have global methods, we have just methods. In Java, data members are called fields or instance variables. No globals, global variables, global functions. We talked about those. I talked about them, and I'm going to skip those. Okay, so these are the primitives. Okay, you cannot say, okay, you cannot say new int Java. For the primitives, new operator doesn't work. Okay, because when you say new int, how are you going to show it? You are going to show it like this, right? Integer I gets the value of new int, but I is an integer, it's not a reference, right? So you can't say that. So a new operator doesn't work with booleans, bytes, characters, shorts, integers, longs, floats, and double. Okay, kind of a non-uniform exceptional rule, but this is how they defined it. Okay, this is how they defined it. Instead, if you like to use your integer, okay, if you like to use your integer as a class object, then they have defined this. They have a class named integer. Okay, its name is integer. It starts with a capital letter, and it's a class. Since it's a class, then you can say, okay, integer I new integer. Okay, and you can set the value of this I. You can get the value of I and that kind of stuff. Okay, so let's look at this definition of integers, and those are actually called, that operation is called actually boxing. Java documentation Oracle integer. Okay, yeah, I'm getting it from SE Standard Edition 8. Other than the Standard Edition SE, there is an Enterprise Edition. I don't remember the difference. Okay, this is the class integer. This is the class integer, yeah. Okay. By the way, class integer derives from class number. Okay. So all the numbers in Java, they derive from class number, and they define stuff on it. Okay. So these are the fields. Well, it looks like it's a, so how many bytes an integer take? Max value, min value, size, and type. These are the constructors. So I can construct an integer from an integer, really, and from a string. And these are the methods. I can get the byte value out of it. I can compare two integers like this. And compare to is very similar to our strcmp. Remember strcmp? That's the compare to. What else? I can get the double value of that integer. I can get the, where is integer value? Do I have the integer value? Yeah, int value, I can get the int value out of it. As long as I remember though, this is an immutable class. Once it is set during the construction, you can change it. Okay, so there are many methods. There are many methods defined for integer class, and related to integers, of course, we have other boxing classes other than the integer. Let me try to find it. Where are the others? C also, very C. Oh, okay, no, not these. I like to find the classes for not integers. Okay, class index, and find double. Yeah, double is here. Okay, double is another class that is used to represent doubles. Okay, of course, this is not a variable double. This is a class double. You need to use the new operator to make one of these. Again, it is like the integer class. It is immutable. Okay, so maybe I will talk about these in a few minutes a little bit more. Okay, good. Any questions? Okay, so we talked about gradebook. We talked about gradebook test. Two classes in the same directory. I compile them separately. Do I have an example of this? Let me go to the, not this one, but this one. Okay. Do I have the, see, my directory is all messed up. Remember I ran javadoc yesterday. Javadoc produced lots of stuff, but I can do this maybe. No, main, adnum, java, main. What is adnum? And okay, let me run this explorer. No, explorer at this point. Okay, let's look at those. I wonder if they are really, how am I gonna, Notepad plus, yeah. Okay, this is the adnum. Yeah, this is the one that I showed you yesterday, the one that defined this. Okay, so the name of this file is adnum java. Okay, this is the javadoc documentation. So if you start your documentation with like /* and star, that means that all of this code, all of this documentation will go to your javadoc documentation. Okay, and you can put this formatting marks inside it. H1 means what? H1 means header. Okay, B means bold, P means paragraph. The author of this file is this person. The version of this code is this, and this is the date of creation of this file. Since I think that the meaning of since is that. So these are special tags for the javadoc utility. Of course, the compiler ignores this whole part, but this ignored part, the documentation, is important for javadoc utility because it nicely formats them. Okay, so this is the adnum method. It talks about it, right? And this is the main method. It says that, okay, params, I am not using it. Okay, and it throws, see, I can throw an exception on input error. Okay, so it is why, because where is my input? Okay, see, this looks funny, right? This main method is part of adnum class. but this main method makes the objects of addNum, right? Even though I can call addNum directly from, oh no, I am doing a mistake. No, do you guys think I can write this? addNum is my method, right? addNum is my method. I am part of this class, and I can call this addNum directly like this, right? Can I write this? It's a C++ question, not Java question. The answer is no. It is no for both Java and C++. Why not?
It will be recursive.
Why? addNum is not calling main. Who calls main? Java Virtual Machine calls main only once, right? Nobody is calling main again. Nobody is calling addNum again. Why would it be recursive? As I said, this is a C++ question, not Java question. Is she sleeping? Wake her up. What are you doing? You come to the class to sleep? Me too, yeah. And I went to bed at 1 a.m. I am not sleeping here, right? And you are doing the same thing every day. Okay, why not?
In order to compile addNum, main needs to be compiled. In order to compile main, addNum needs to be compiled.
No, why not?
We don't create objects.
What? What?
AddNum is not a static object, a static method. So we have to create an object.
Yeah, main is a static method, right? Static methods would not call non-static methods, right, by their names because there is no object when you call main. So it has to be, there has to be an object. Okay, I made an object. Yeah.
So main function has to be static also.
Main method. Yeah, main has to be static, otherwise it doesn't work. That's the definition of Java. What's the definition of C? What's the definition of C++? If you're writing an executable program, it has to have one main function, right? So if you are going to write an executable Java file, it has to include a public static void main inside a class that has the same name as the file name. Okay. Good. Any questions on this? Okay, so I showed the main method, I showed the addNum, and I think this file is written just to demonstrate how the Java doc works. But anyways, so I could have done this public static int addNum, and in that case addNum would have worked. But it is interesting that I am making objects of the same class inside the class. Sometimes we do that. Okay. Good. Let's go back. We talked about control statements, logical operators, packages. We talked about them. Okay. And these are some of the packages. Java Lang is an important one, as I said. You don't have to import Java Lang to use it because it is automatically imported. Some of the important classes, like the string classes in Java Lang. I believe that integer double and that kind of those class versions of it are, where are they? Are they Java? Yeah, is that? Yeah, see, it is inside Java language, right? So, as I said, it is an important class or package. Okay, these are about networking, text processing, utilities. Remember scanner. We'll talk about this swing and abstract windowing toolkit, Java abstract window toolkit package. This is about GUI, graphical user interfaces. And I think I will spend 1 or 2 lectures about this graphical user interfaces. And your last homework number 8, will be about implementation of Tetris using the graphical user interfaces. Okay, so shadowing, overloading, scoping, it is very similar to C++. Let's look at this example. I have a class named scope, okay? It has a private integer, and as you see, it can be initialized like C++ 11. Its initial value is 1. Let me get rid of these. Do I have any of them? Okay, good. Okay, so okay, so its initial value is 1. Then I have a method, non-static method named begin. Begin starts with this line. Okay, begin starts with this line. Integer x 5. Okay, so what is the title of this slide? Scoping, shadowing, and overloading. Okay, this x and this x, they have the same name, so we call this x is shadowing this field x. Okay, it's not a compiler error, it is just shadowing it. Okay, so whenever I modify this x, I have nothing to do with this x. It's a different x. So when I run this line 15, if somebody calls this begin, okay, and after that x is 5, and when I run this line 15, it tries to print this number x, whose value is 5. Okay, so it is printed on the screen 5. It is not 1, it is 5. Then I call this use local variable, use field, use local variable, use field methods, one after the other one. And then, okay, question for you. What does the line 22 print? I told you what 15 prints. It prints 5. How about 22? What does the line 22 print? You might say that we don't know what these are doing, right? You don't know what these are doing, that's why I cannot tell. No, that's not the answer. Doesn't matter what these lines are doing, they cannot modify the value of x, because x is my local variable, right? X is my local variable, it's 5. I know it, okay? Since I didn't send x by call by value to somebody else, its value cannot be changed, it is on my stack, okay? So this definitely, this line will print 5, and this line will print 5 too, okay? And we didn't look in what is available in use local use field, okay? Let's go to use local variable method. Use local variable is, oh surprise, it makes a new local variable. Now it is our third x. Again, now it's going to, this one is going to shadow. Okay, question for you. X shadows which one? This one or this one? Does it shadow line 13 or does it shadow line 7?
Line 7.
Yeah. There is no way that line 7 is the correct answer. There is no way that line 28 would shadow line 13, because at line 28, I don't have access to line 13, right? I have nothing to do with it. So, but this one will shadow my private field, okay, private field. If I didn't have this line, this one would have printed, okay, 1. If I didn't have this one, okay. If I didn't have this line, again, this one would have printed 1 on the screen, but it is not going to, because I will do this, okay. This one will print 25. This one will increment it by 1, 26, right? And this one will increase it. This one will print 26. Doesn't matter how many times I call this use local variable, it will always print it will always print 25 and 26.
At line 17, doesn't use local variable.
Are you cold?
No.
Really? You're okay?
Yeah.
Okay.
At line 17, doesn't use local variable shadow x is 5.
Let's say it again.
At line 17, doesn't use local variable shadow x.
17, you mean?
Yeah.
Yeah. Well, I calling this use local variable. Use local variable has its own local variable in it. So it has nothing to do with my local variable here, this one, or my private integer.
Does it shadow 5 as well?
You mean this one?
Yeah.
No. To shadow something, you have to have an access to it, right? At line 28, I don't have access to line 13. Because I have a method, I am calling another method. Remember, methods don't have access to, okay, remember methods, they don't have access to other methods, local variables. Okay, good. So another one is use field. Let's go to use field. And use field, as you might have expected, it doesn't define any local variables named x. It just directly prints this x, whatever the value of it. Okay, so it will print what? Use field when I call it from this method. Use local is okay. This one printed 25 and 26, right? How about this use field? Use field is going to print, it will print 1 and this one. This will be 10, right? 1 and 10. If I call use field again, it's going to print 10 and 100, right? 10 and 100. Why? Because every time it is updating my field, private integer field, and since it's a private integer field, it is my data field, then I need to keep its value, right? As long as the object is alive. So, so this one is going to print 1 and 10. I am going to call the use local variable. It's going to print, doesn't matter how many times it will be called, it will be printing 25 and 26. But if I call use field again, it will be 100, 10 and 100. Okay, and at the end it will print 5 when I do this begin. Who calls begin? Let's look at this one. Who calls begin? Okay, so this is the second file. See, I have two files in this program set. One is the scope Java, public class scope. Okay, the second one is scope test, public class scope test. It includes a public static void main. And this one makes a new scope object and it calls its main. And as we have expected, 5 and 5, 25, 26, local, use field, use local, use field. Okay? Good. Any questions? So, I didn't say much about object-oriented programming. I'm just trying to tell you how the methods are written, how the methods are called, and that kind of stuff. We will start talking about object-oriented rules maybe end of this today, maybe tomorrow. But I mean, the by itself, writing a class, defining member fields, member methods, etc. These are the principles of object-oriented programming. Okay, I'm going to talk about arrays. Arrays are reference types. Okay, they are reference types. They are not pointers, of course. They are reference types. They are not primitive types, and this is how you make an array. This is how you do it. This is an array. It's a very okay. When you look at it, it's an integer array. That's it. It's an integer array. But C is not an integer array. C is a reference to an integer array. Okay? To make a new integer array, you need to use the new operator. Okay? You are saying that give me an array of integers of size 12. And it gives you that, okay? So this is not an integer array declaration. This is an integer array reference, okay? And I make the array using the new operator. And again, if the reference count drops to 0 for this integer array, okay, then it will be deleted automatically. Okay, so that's it. That's the basic idea of the arrays, but it has some consequences that you need to be careful about. Okay, let's see an example.
Hocam, may I say something?
Sure.
Before we mentioned that when we create a object, maybe
Using new operator.
primitive types, we use special classes. Big,
Yeah.
big letters, integer.
Yeah.
If you write there,
You mean the
One.
integer, new integer with a capital letter?
1 instead of 12. Is it the same thing with the before?
No, it is not actually. Let me complete my discussion about arrays, and maybe if I don't forget, I will talk about that. Okay. Well, in fact, I will talk about that when I come to boxing and unboxing. Let's delay that discussion for a few minutes. That's a good question. Okay. Arrays in Java, they know their lengths. Okay. When you ask this C, what is your length? C.length, it will tell you it's like the vector. But it's not like the vector that you can extend, you can push back. Its size is fixed, but you create it. It's like an STD array with a capital A, remember? STD array, okay? So let's see one example. Here is the example. Static void main, okay? I have an integer array. Well, this is a way of declaring arrays, but we don't like it. The correct way is, or the preferred way is this way. Integer, square brackets, and array. Both of them are the same, but we like it this way. This book gave an example just to show it that it is possible too. And I make this 10, okay? So my array is declared, okay, this name array is in this stack. This integer array is on my heap, okay? And this is a reference, smart pointer to that array. Okay, from 0 to array length, you increment the counter 1 by 1, and I print it out on the screen like that. Index operator works, of course. Okay, so these are the arrays of Java, and it looks like my initial values are zeros. Okay, my initial values are zeros. They are initialized with 0. Okay, when I make arrays of objects like this, money array MA, right, gets this new money 10. Let me make a better new. Money is new money 10. Okay. Question, what happened? Tell me what happened. In my memory, I made, okay, in my stack, there is a reference called MA, right? MA is pointing to an array of what? No. Array is pointing to, okay, MA is pointing to the array of money references. Each of these is a money reference. That's what you are saying. Okay? Give me an array of money references. How come we didn't say the same thing for the integers? Well, there is no integer reference. That's why it makes integers. Okay? 10 integers. This one makes, okay, 10 money references. And if you like to if you like to put many objects, okay, around your memory pointed by those many references, then you need to do this. From 0 to MA length, for each of those MA money reference, make this assignment. New money, $10 and I cents. Okay? Okay, so sounds kind of doing this, pointing to your ear with the other hand, but no, actually it is. I mean, when you think about it, other than that, there is no way to do it. Okay, so that way you have to explicitly call your constructors one by one, right? Call your constructors one by one. Remember, we had this problem in C++ when say, if you don't have a no parameter constructor for your class, you can't make the array of that. No, this is not valid anymore. You choose whatever constructor you like to use for each of those objects. Okay? If you don't initialize it, if you don't initialize your money references, they are all null pointers. They are not pointing to anywhere. So this is how this line looks like. And after the loop, it's going to point to places in memory like the money object, and money object, and money object. Okay? Sounds crazy, and who is going to clean up all that mess? Well, you don't have to think about it, as I said before. If the reference count drops to 0, it will be cleared automatically. Good? Yeah.
Are these references created in stack? Are they those references?
Well, whatever you use, if you use new operator to make something new, then it is on heap, right? So how many things, I mean, out of how many things are happening? There is an MA, this is on my stack. When you say new money 10, it is on my heap. Each of these money objects are there on my heap. So there are 10 money objects on my heap. There is an array of size 10 of money reference on my heap, and there is a single local variable MA on my stack. So it looks like Java doesn't use stack much, right? Only the local variables, return address, parameters, and etc. Good. Okay. Well, in Java we have range for loop. We call it enhanced for statement, and it works this way. You put parameters and array name. Do I have an example? Yeah. If you like, you can initialize your array like this. Array, integer array, initialize that way. Int number array, total plus assignment number. Okay, good. Where is Abdurrahman? Did you see him recently? It was his turn to ask about auto in Java. There is no auto in Java, but I think they have introduced something like, do I have it? Yeah, here it is. Okay. It is var, variable kind of thing. So you can say, instead of saying here integer number, we would say auto number, right? No, we say var, variable, number array. Okay. So it works. Like, remember the iterators, and writing the iterator name is a very long thing. So when you say, I need a new array list of strings, you don't have to repeat the same thing here, okay? I don't care what list stream returns, stream is that, right? So I think they have introduced this in Java SE 10. I don't know who introduces first, auto or var. Which one came before, auto or? If Google can understand this and give me a right answer, what was auto used before? No, it didn't understand it. Which one came before? C++ auto or Java? I think this way. Is there auto type in Java? Which is like C++? Yeah. It looks like auto, well, auto is before var, right? You can finally declare info, yeah, okay. So somebody is criticizing Java. So auto is before var, so usually it is the other way around since Java is a newer language. Whatever Java introduced, they later added that kind of stuff. Range for loop was, okay, this one. And as for statement was there in am I wrong? I don't know. Maybe they just introduced at the same time. I'm not sure. Anyways, I mean, usually this kind of useful, we call this syntactic sugar. Okay. I mean, you don't need it, but it makes your life a lot easier. Okay. So they kind of copy these kind of mechanisms between each other, and C++ standards committee and Java something committee, I bet they have some common people between them, so those people know the other languages very well. Okay, passing data to methods. In Java, there is no call by reference. It is all call by value. Everything is call by value. Okay, pass by value. It talks about pass by reference, but it is not. It is like C, exactly like C. Okay, what did we do in C to achieve pass by reference, call by reference? We send a pointer, right? In Java, we do the same thing too. We send a reference. If you send a reference to a function, to a method, if that method modifies that object through that reference, then you get the effect of pass by reference. Okay, so I don't know what I have written here, but okay, if this function f takes a money object, well, it doesn't take a money object because you cannot hold objects in your hand in Java, right? This money m means it's a reference to a money object, right? So this one is expecting to get a money reference. Okay, expecting to get a money reference, and this is my local variable m. If I modify this m, m gets such, okay, and if I call this f with this m, of course this m will not get affected. Why? Because m is my local variable, right? M is my local variable. But if I do this, don't modify m, but do this m dot set dollars, right? Set dollars 10. Of course, the money object that you have sent will get affected because I am modifying something through the reference. Of course, I need to make a new money object here. Okay? So in Java, everything is called by value. If you like to get the effect of call by reference, send the reference to that method and use the public methods of that object to modify the referred or pointed object. Okay? So that's it. But usually, if you take Java as the first programming language in as a programmer, as an engineer, they talk about pass by value, pass by reference, and they refer to the sending objects to the method as pass by reference, but it is not. Like they did in C++, right? They told you that there are two ways to achieve the sending objects to or variables to other methods. Then they told you that you can do it with the pointers. That's called call by reference. But in fact, what you are doing is call by value all the time. Yes?
Sending a reference is same as C++.
No, but that's what I'm saying. There is no call by reference in Java. C++ reference and Java reference are two completely different things. Remember what I said at the beginning of the Java lectures? When I said, if two things are called the same thing in Java and C++, they usually mean the same thing, but they completely mess it up when it comes to term reference. Java reference is very different than C++ reference. Java reference is C++ smart pointer, okay? So Java reference is a pointer. When you send a reference to a method, you are sending a pointer actually.
We said everything is a pointer in Java, but when we pass an argument, it's become a pass by value. I didn't understand.
Well, I am writing in C now. I have a function, integer function. This integer function, let's take, it takes a character pointer, right? Okay? So when you send a character pointer to this function, what are you doing? You are sending a character pointer by value, right? It's the exact same thing. So references are pointers, smart pointers, but they are pointers. And when you send an object to a method, you are not sending an object because, as I said, you cannot hold an object in your hand in Java. Only you can do is you get the handle of it. That handle is the reference. Okay? Good. Let's get some break. 10 minutes, okay? It's not 30 minutes. 10 minutes. Evet.
Template class yazdığımda direkt class içine yazabilir miyim? Diğer türlü sorun veriyor ya genelde. Veyahut CPP'yi dahil etmem gerekiyor ya. Ayırsam implementation'da header'ı.
Zaten genelde öyle yapıyoruz. Ama include edeceksin onu. Bence header'ına yap. Ya da bizim compiler'ımız, sana verdiğim compiler, size verdiğimiz o VirtualBox onu kabul ediyor. Header'ına ayrıca yazabiliyorsun onu.
Aynen. Ama o zaman işte CPP'yi dahil edeceğim ya yine. Header'ı dahil edince olmuyor sanki.
CPP'yi include ediyorsun mecburen, evet. Header'la beraber.
Aha.
Genelde ben header'ını include ediyorum. Header'da CPP include ediyorum.
Anladım. Tamam. Ya içinde yazsak olmaz mı? Ayrı mı yazayım? Hani ödevler.
Ya öbür türlü yaz. Doğru yapmaya çalış. Çünkü sen o da CPP'yi include ettiğin için.
Anladım. Bismillah.
Merhaba Elif Hanım.
Bunu silerken hasta değil.
Teşekkürler. Sizler nasılsınız?
Alerjim var benim. Kanka bir daha aralığın ortasında alerji. Şimdi kalkarsan bir daha yanına tutamaz. Aralığın ortasında alerjin mi az daha? Soğuk olunca öyle oluyor. Soğuktan alerji. Evet. Hastalanma da diyorsun. Hayır kanka, hasta olsam söylerim. Nasıl ayırt ediyorsun kendini? Boğazım ağrıyor. Nasıl ağrıyor? Sen oraya geçiyorsun. Ama benim şey yok. Yok öyle. Geçmeyecek oğlum adamımız ondan. Başka yere geç. Kutulandım ya. Sen kanka kutulan geç sağında olur mu?
Yok çantaları geç. Ben atlıyorum.
Çantıyor da.
Çantalardan düşmüş.
Güzel mi?
Evet.
Sonradan aşağı koymuşlar. Driver dışından daha uzun zaman alacak.
Ben
Bir bak kaldı şey yapayım. Kutudan çıkalım ve
Evet. Şeyin peki dersen ismi ne olacak?
Ama hiç double free aldım. Sen double free yap.
Kompaylı bir kadar.
Yok olabilir, yok olabilir, ben olmaz değil mi? Olabilir.
1 lira ver. 2 lira ver.
Niye?
Maske kartla alabiliyor musun?
Maske. Onu da.
Yok, esasında çok da oraya gitmiyor. Bunlar mühendis oldukları için, yani bilgisayarcı değil bunlar. Bilgisayarcıların almasını şey yapacağız, engelleyeceğiz. Çünkü diğerlerini eziyor onları aldıkları zaman otur derslerde. Evlilerin moralı falan bozuyor.
Evet 2 lira.
Yani
Evet
dolayısıyla
sağ Allah'ın
şey
tanesi.
yani,
Şuralarda boş yer var.
yüksek lisansla
O zaman sus. Niye susuyorsun birader? Niye susuyorsun? Susturmaya çalışıyorum ben. Tamam kanka bir daha yarın oturma sonra sesimizi Sıktırmayız. Ama ben astroloji taktım abi.
Ha, şu Covid kuralları artık geçerli değil.
Covid değil abi, normal astroloji.
Tamam işte. Bir sene sen şey diyor muydun birine? Kanatsız maske taklayabiliyor muydun? Bilemedim.
Yani Türkiye'de o kültür yok maalesef.
Bana niye o zaman davetiyonu da var?
Ben yaptım çünkü ben feda ettim.
Ben sana öyle bir şey istedim mi?
Ben kendimi feda ettim. Geri dönmüyorum sonra.
Sana ve çok tutarım yani. Kayıt altında. Başınıza ek şey yapabilir.
Balıkçı abilerini çağıracağım.
Tiyatro oyunuydu düşündüğüm
Evet.
her şey. Senaryo okuyoruz. Senaristimiz de yandaki adam.
Ben mi?
Evet evet.
Bunu beğendiniz mi?
Güzeldi ya bence değil mi?
Ben
Evet, iyi
neydi
miydi?
onu boşver.
İyi miydi?
Yok ya. Sen de
Double
çok
Curry'i aldım.
Sen de çok kötü.
Ben sevdim ama iyi senaryo.
Double Curry beni bitirdi.
Herkes başka bir şey olmaz.
Hadi senin de bitti de.
Yemin ediyorum ha.
Daha bu bonfire etmem.
Oğlum yazdım da.
Şey,
Çok anlayamıyor işte.
ne?
Biraz salak compiler, benim kodu çözemiyor.
Allah Allah yapma ya.
İşte. Gelişsinler yani şey yapsınlar. Ben dedim ki yani orada yazdım. Kodu yaz diye yazdım.
Güvenlik kendi tersini
Noktalı.
alınca
Anlamıyor, hata veriyor. Bu
double
ne?
Curry görüyor.
Yani acil inovasyon getirmesi lazım compiler.
Kendi compiler'ını yap.
Ödevi yap diyorum, yapmıyor.
Seni anlayan compiler'ı.
Allah. Compiler yazmak için compiler'a ihtiyacım yok. Assembler kullan. Assembler'da yazacağım. Ben anlıyorum. Yap diyeceksin, yapacak.
Compiler yanlış compiler gözüküyorsa ilk compiler'ını yapıyorsun.
Assembly'de makine koduyla yazalım.
Makine bunu ne?
Makine kodu bir sıfırda yapacağını belirtiyorsun. Assembly şey yapıyor sadece. Sadece şey yapmıyor. O kadar basit değil. Yani assembly biraz daha soyutlu senin için. Fonksiyonlar falan var. Şeyde makine kodunu yok her şey. Önce 1.0 diyor. 1.0 diyor. Çiğ köfte yemek.
Perşembe gelen taraf olur musun?
2 haftaya falan oluyor bu arada. Geçen hafta mı? Öteki hafta mı? Ne oldu?
Şimdi foto sınavı var ha.
Öyle bir şey oldu.
%25 ya. Boş ver girmeyin.
Yarın asıl sınav yarın olur.
Ben alıyor muydum o dersten ben?
Alıyorum.
Tamam. Çalışırız ya. Bakarız.
Bugün sörtü şeyi de var. Acayip sınav
Yok
var.
abi sürküt gazı sıfır aldık da şey.
Hakikaten 106 yok 50 üstü alabilir yani cin gibi.
Müşterimiz birleştirsek ben.
Yok.
Ama işte kullanmıyorum. Ben buraya kalkar mısın?
Hayır. Şuraya yere kadar kalkmam.
Ben buraya kalkar.
Az kaldı.
Neden?
Az kaldı.
Neden?
Oldu be. Takma lan.
Ver bunu.
Takma. O yerine değiştir oğlum bana.
Bozuk ver.
Bozuk ver. Bozuk ver abi.
Amca bak takmışsın ya.
Normal yol yollayın. Oğlum bu maske değil, buranı rahatsız ediyor.
Niye öyle kaldı?
Sesler var.
çoğu telefonda telefon sizde olsa bile alarm çalıyor. Büyük ihtimalle yeni telefonda çalıyor. Hatta bazı telefonlar kapalıyken bile alarm çalabiliyor.
Yok abi.
Çok eski telefonlar tuşlu. Bizde var bir tane.
Allah abi fakat yapabileceği çok az.
Nasıl oynatacak?
Gelmiş balıkçı gibi adam.
Gebze verdiği
Sayın Bey nasıl gidiyor?
İyi gidiyor. Sizden nasıl?
Geliyor bayağı. Derse şurada oturacak. Bağlantı yazacaksın. Böyle desek
Kar yağacak biliyor musun? Kar yağacak. Bir başı geldi. Yani öyle mi yapacak?
güzel. 2 hafta içinde yazacak. Hani 2 hafta içinde kıyamet de koparır.
2 hafta içinde %90 kar yağacak.
İnşallah. Salı günü gelir.
Bomboş.
Şurada oldu gibi. Çarşamba mı? Çarşamba pazartesi olsun.
İlla ki hataları neyse. Şeyler yok
Ben ders alamam.
Sürüler de var. Olabilir kar yani.
Öyle bir yer yok. İnternet hatları falan da kapatıyor.
Araya bile çıkmamış, gördün mü?
Cep çıktı hemen geldi.
Eve mi geldi? En çok da ikinci derse geç gelip otobüs geç geldi diyenler hoşuma gidiyor.
Ben de oraya gittim. Ben de
Okay, so there is no call by reference in Java, and you cannot, whatever you do, if you take an integer in your method m1, okay, m1 there is no way that you can modify the value of this I and return it that way. You can't do that, right? Because I is passed by call by value. There is no call by reference. And you might say that I am going to hold a reference to this I using the new operator. No, you can't do that because new doesn't work with integers. So you cannot use any call by reference operations for the integers, whatever you do. Maybe you can take this as an integer, okay? Void m2 integer, okay? Integer I. Since integer is a reference type, maybe you can say that it's a pointer I can modify, but remember integer is an immutable class. You may not modify its value, right? Whatever it holds, you cannot change it. So it is difficult to get this effect. That means that you are going to write the class. Inside the class there is an integer and you are modifying it and etc. Okay. So Java says that if you are going to modify this integer, just return it. Don't modify it through the parameters. Okay. Good. I am going to skip this one. No, maybe not. Well, I think I'm going to skip it now. Yeah. Command line arguments. It works. Remember, my parameter to the main method is something like this: string arguments. Okay. When you call your Java virtual machine with my class, okay, and these are your command line arguments. Let's look at this program. Very simple program. Init array. Java init array is the class name. Method main. Okay, these are my arguments. See, I am asking this question. What is your length? How many parameters did you pass to me? If it is not 3, then I will say, error, please re-enter the entire command, including array size, initial value, and increment. Let me show you one example output, then later we are going to, okay. When you say Java init array, Java virtual machine init array, it says that error, you cannot call me like that. If you call it like this, Java init array 504, okay, it's going to make an array of size 5, 1, 2, 3, 4, 5, and starting from 0, by the increments of 4, it's going to fill in this array and print it out. And if I do this, array of size 10, starting from the value of 1, increments of 2, do this. Okay, so these are the results, how it's going to work. Let's look at the implementation now. If the number of parameters is not 3, okay, that's the size of the array, initial value of the increments. If it is not 3, then print this out. If it is 3, then see, get the argument number 0, which should be the size of the array, but it's a string, right? I need to convert to an integer, and this is how you do it. I call the parse int static method of integer class. Class integer has a static method of parse int. I send this arg0 to that integer class static method, and it's going to return me an integer. Okay, now I convert it to an integer. I make a new integer array out of it. Okay, I have now that many integers in my array. Then initial value and increment, I am going to do the same thing for the integer class. and from 0 to array length, put that initial value plus increment times counter to that array counter. And then I print this header, okay, format it nicely, %s, %8s index and value, then in a loop from 0 to array length, print them out. Okay, I am using the printer now. I am printing the array values now. Okay. Good, so this is how you use the command line arguments. This is how you use the arrays. So the command line arguments are actually just array of strings, okay? By the way, in Java, the string starts with a capital letter S. In C++, it starts with a small case letter S. Good. Let's move on. Constructors, of course, overloading is exactly like C++. And that applies to constructors too. Okay. So no argument constructor, and can call the other constructors. Remember, in C++ constructor delegation, we have exactly the same thing in Java, and it works this way. Let's say I have a class named time. Well, let me show you the the client code. No, I don't have the client code, sorry. My time class, it has 3 private integers, hour, minute, and second. So it is like hour is 13. Okay, hour is 13, a minute is 15, and the second is 55, something like that. So I'm going to keep each of these hour, minute, and second as an integer. It's an overkill, but, well, this is what I have. Okay, so this is my no parameter constructor. It says that, okay, no parameter constructor calls the constructor that takes 3 parameters with 0, 0, 0. This is how you delegate your overloaded constructors. So let's look at the 3 parameter constructor. Where is it? It is here. Okay, 1, 2, 3. So this one in turn calls set time. Set time is here. Set time calls set hour, set minute, and set second. It looks like set hour, set minute, and set seconds are going to check error for errors, and they are going to set the corresponding element of this class. The important thing here is using this keyword. Okay, this is a keyword in Java, like in C++. You can call the other constructor. So this no parameter constructor calls 3 parameter constructors. This 1 parameter constructor calls again 3 parameter constructors. It goes that way, and in turn this 3 parameter constructor calls this set time. And this looks like a copy constructor, right? It takes another time and it sets my time out of that time. In Java there are no copy constructors. Okay? In Java there are no copy constructors. In Java there is no assignment of, well, I should be careful about that. In Java there is no operator overloading. Okay? In Java there are no copy constructors. Well, I mean, you might say that, isn't this a copy constructor? Yeah, if you write it that way, it looks like a copy constructor, but nobody calls it copy constructor. Okay, nobody calls it the copy constructor, because copy constructors are not special in Java. Well, question for you. Why are we so careful about copy constructors in C++? Yeah.
Automatic call by value function.
Yeah. Exactly. So when we do the call by value, the copy of that object is taken by the copy constructor. In Java, we don't have such a problem or such a concern. Why not? Because I cannot send my objects call by value, right? Because I cannot hold my objects in my hand. I only have their handles. I can send the references to the objects, and they are called by value and no problem, right? So in Java, when this time I am taking here is not a time object, okay? It's time object's reference, okay? It's time object reference. So I am not making any automatic copies of objects by default. So there are no default copy constructors, okay? There are no default assignment operators. And question for you, let's look at this one. This is not a new thing. Maybe you could have guessed it before, but let me write it, okay? Let's say I have money references M1 and M2. M1 is new money $10.20. M2 is new money $5.05. Let's draw the memory. This is M1, this is M2, right? M2 is pointing to some location, $5.05. This one is pointing to some location, $10.20. Okay, that's the picture, right? What happens if I do this? M1 gets the value of M2. What did I say? There is no assignment operator in Java. I mean, I didn't say that, but I want to say that too. But then let's say I'm saying it. Okay, there is no assignment operator in Java. When I do this, what does that mean? M1 gets the value of M2. It's a pointer assignment, right? So M1 is now pointing to this location, right? That's what's happening. It's not copying of the whole object, right? I am not doing this memory assignment, or I'm not doing this pointer assignment. That's it. How am I gonna copy this money to this money? Well, that's a different thing. Most of the time, most of the Java people don't know how to do that. They don't know how to copy the content of this money over to this one. They don't know how to do that. Most of the time, they don't need it. And if you tell them, they don't understand what's going on, etc. But that's the meaning of it, okay? I just did not copy anything. I just copied the reference. Okay, I just copied the reference. If you like to make a copy of this one, okay, this object itself, you need to do something else, and we are going to talk about it. That's going to be the surprise. I mean, maybe the shocking part of it, and you are going to like it. Yeah.
What if we change M2 to M1 change?
What do you mean? Of course. I mean, these are both pointing to the same location, right? When you say M1 set $30, this one is going to be 30. They are pointing to the same location, right? They are pointing to the same location. How about this? What does this do? If M1, M2. What am I asking here? Okay, let me get rid of this one. This is my, okay, 5. Both of them are $5.05. Would this return a true for me or false?
False.
Why not? Because M1 is different than, because picture is like that, right? Because M1 is different than M2, right? M1 is pointing to this one, M2 is, this is comparing two pointers, not the objects themselves, right? What are you going to do to compare two objects? Then in that case, you are going to do this. If you like to compare two objects, then you write an equals function method and send the other one, right? if you write it, then, and if it works right, then it will be okay now. Okay, good. So, well, I didn't say anything new right now, but I'm just trying to make some points just to make you realize that this is what's happening. Okay, so we talked about this delegation or the overloading and constructors calling each other. We talked about those. Good. Okay, are there any questions? No default arguments in Java. You can't say this. Okay, 0, right? We used to say that, right? No, you can't. No default argument list for Java. You have to write them one by one. But you may overload your methods as many times as you like. We don't have destructors in Java, but we have finalize method. Okay, finalize method. Finalize method of a class is automatically defined, and it is called automatically when the object dies. Okay, when does the object die? An object dies if nobody points to it, no references refer to that object. That object may die. I am not saying it's going to die. The object may die anytime. Who is going to kill it? There is a process, there is a thread named garbage collector. Garbage collector runs from time to time while JVM is running. That garbage collector checks all the objects to see if their references are 0 or not. If it is 0, it kills them. Okay? When it kills them, it calls their finalize methods. Okay? So if you like, you can write your finalize method in your class. Okay? That finalize method will be called automatically when your object dies. But you don't know when your object is going to die, because what did I say? Its reference count should be dropping to 0. Okay, its reference count should be dropped to 0. Even if it is 0, garbage collector may think that, well, I have memory anyways, and this is not memory leak, I know where they live. I'm going to kill them if I need more memory, right? So most of the time it lives as them, as they are. It doesn't kill them, or it keeps them alive, although nobody can access them. Okay, it kills them as it keeps them as they are. And if I am out of memory, or up to the garbage collection's memory management philosophy, actually, it may kill them at a later time. But if you like to kill all the objects that has a reference count of 0, you may force your garbage collector to kill them. Okay, and this I'm going to show you how. Okay, I have an employee class, very simple one, first name and last name. It looks like we are going to count the number of employees in my memory. Okay, private static integer count, and its value is initial value is 0. Okay, employee constructor first last, get them, set them, reference sets, count is incremented by 1, and my constructor prints this one. I have constructed an employee with this count, and I increment the count by 1 all the time. I have a single constructor, I guess. Yeah, I have a single constructor. That's it. This is the only way to construct an employee, using the new operator and employee constructor. And then what? Okay, I'm going to come back to the finalize later. Get first name, get last name getters. Get count is a static method that will return the number of employees constructed, right? Return count. Because this count is only incremented by the constructor, and this one returns the count. Okay. And getters are there. And let's look at this finalize. It looks like finalize is protected. Why is it protected? Well, nobody's going to call finalize. It's like private, right? And we might have a hierarchy too. So it is protected. We define it that way. And Finalize, remember, finalize is called when nobody refers to this object and the garbage collector is killing it. Finalize is not automatically called when the reference count drops to 0, okay? It is called when our object is being killed, okay? So when the object is killed is defined up to, is defined by the garbage collector. Of course, the reference count should be 0, but reference count should be 0 doesn't mean automatically killing that object at that time. Okay, so I am saying that I am killing somebody and name, first name, last name, and the count is here. Okay, so this is our employee, Java employee class. Let's write another file, employee test Java, employee test. This is our main method. See, this is nice. Before I made any objects, or if I constructed any objects of employee class, I use a getCount method, static method of employee class, to print the number of employees, existing employees. Of course, as expected, that's going to print 0 on the screen. No object is yet, created yet. This one will make an object, this one will make another object. Object number 1, object number 2, 2 objects. And after that, I will call this getCount in 3 different ways. E1 getCount will print what? E1 will getCount will print what? What? What?
Number of elements.
So what does it going to print? You're going to tell me an integer. 0, 1, 2, 3, 4, 5, 6, what?
1.
What?
1 version.
Why?
Because we only created E1.
What is getCount? GetCount prints the count. Count is the static data, static field, okay, and it is incremented by 1. So it will print what?
2.
It will print 2. This one will print 2. By the way, this is a C++ question, not a Java question. This one will print 0 after constructing 2 objects. This one will print 2. This one will print 2, and this one will print 2 too. Okay? And then I do this, okay? Get their first names and last names, etc. I do this assignment, E1 assign null, E2 assign null. What does that mean? Nobody is pointing to this employee 1 object anymore. And nobody is pointing to employee 2 objects anymore, right? Their reference count dropped to 0. They are free to die. They are free to die. Garbage collector can kill them anytime. But as I said before, garbage collector is not going to run every time you made a change in your objects. Okay? It only runs whenever it is needed. If I don't have enough memory and that kind of stuff, okay? So after these 2 lines, I am not sure if my object, employee object Susan Baker and employee object Bob Blue will be dead yet. But when I force the garbage collector, system.gc, this is how we call the garbage collector, okay? Garbage collector run and delete all the objects not referenced anymore with the reference count 0, okay? That will do it, and that will kill them, and it will call their finalize method. And after that, when I say employee.getCount, it's going to print 0, of course. Yeah.
Garbage collector is called after the main example.
No, not necessarily. Well, after the main, it is definitely called, but from time to time, Java virtual machine makes that decision.
Okay, then we can say that really that there is no leak on Java.
Well, in Java, there are no memory leaks. We don't call them memory leaks, okay? Memory leaks is something, you have some piece of memory and there is no way that you can return it back. It is all wasted. This one says that, okay, I know that they are there and they are free to die now, okay, but I am not going to kill them because I don't need the memory. Deleting some object, okay, giving the memory back takes CPU time, it is inefficient. So Java says that why are we killing them at the same time that they are available to be killed, okay? I'm going to wait until I need some memory. If I don't have that memory requirement, if I don't have that memory need, then I am going to wait, okay? They can stay there. I'm not going to spend any CPU time on it. In C++, it is different. I mean, in the same loop, I make a new and delete, it immediately deletes the object, right? Even though you have the memory, you have to delete it. You have to give the memory back to the operating system or the memory management system. Okay, so this kind of efficient, but garbage collector is a thread, is a piece of software again. It has to run on the CPU, and from time to time, Java will take the CPU away from you, and it is going to do some housekeeping, which will make your Java programs a little bit slower. Especially at the wrong time critical phase of your software, Java collector started, garbage collector started running and cleaning your memory is not going to be something good that you like. Okay?
Can we control that?
What?
Can we control that?
Well, there is some control of it, but you are not, it is not suggested that you play with the Java garbage collectors running times and etc. Let it handle it again. Say that I'm going to run a separate thread and you will not get affected. And since we have more than one core for many computers nowadays, so one of the cores will be dealing with the Java collector, the other one is running the code itself. Okay? Okay, so we talked about this. So this was a kind of a review of static data members, static methods. And as I said before, we don't have destructors in Java. Instead, we have the finalize method, but the finalize method is not the same as the destructor. Destructor, we know when the destructor is going to be called. Okay, so at the beginning, before the instantiation, number of objects is 0. Constructor of Susan Baker, the count became 1. Constructor of Bob Blue, count is 2. Employee 1 get count is 2. Employee 2 get count is 2. Employee get count is 2. These are their information. And when the employee finalizer is called, this is what happens. I don't know the order of the finalizer, Bob Blue or Susan Baker, first or last. I don't know. It is up to the garbage collector. Okay, good. Any questions? Okay, this final instance variables, as I said, there is no const keyword in Java. Okay, there is no const keyword in Java. To accomplish what we are doing with the const, remember we have the const in C++. For example, we had the const method, const functions in C++, right? In Java, we don't have it. If you have a parameter like, instead we said we have final. If you have a final parameter like this, void final money meo, okay? You can set the dollars to it, no problem. The final thing here is that the constant here is the money, the MO. You cannot change its value, right? You cannot change its value. It is not the objects setting stuff, right? There are no constant objects, like you cannot change this thing. Remember the constant references in C++? We don't have it. That's why they don't have the const keyword. What happens if I like to do this? I mean, I am going to send you an object, but you are not going to modify it. How are you going to do that? It is not that easy, but Java has a more general way of achieving it. I think I have an example somewhere. Where is it? Let me find it. Yeah, here it is. You build a hierarchy, okay? You say that my money class will have two parts. One is an immutable money, okay? In the immutable money, you have only the getters. And when you derive a new class named money out of this immutable, okay, it is money, and that money has set dollars and set cents part, okay? Since there is a relationship, whoever needs an immutable money, I can send the money. But if somebody needs a money object, you cannot send immutable money. So what does that mean? If you don't like, if your method says, okay, method M1, if my method M1 takes immutable money, what does that mean? M1 cannot modify your money object, right? If your M2 takes a money object, then M2 can modify that money object, right? If you have a money object in your hand, you can send it to both of them. But if you have an immutable money object, you cannot send it to money, right? This one and two. So that's a solution for you. You don't have the constant keyword or constant money references, constant object references, but you can find the solution. Okay? You can find such a solution. So let's go back and let's talk about what we mean by final. Okay? Principle of least privilege, we talked about it. Keyword final, and it is used in many places. Let's look at this implementation. This is a class increment. It has a private integer total and private final integer increment. Okay? What does that mean? If I like, I can change this total to any value that I like, but I can't change this increment value because it is final. So if we can't change it, how am I going to modify it to give an initial value? Of course, in the constructor, I can change it. Constructor gives that initial value, but afterwards, nobody can change it. So the constructor takes the increment value there, and every time I call this add increment to total, it will increment this total by this amount, okay, one by one. Doesn't matter how many times you call it. You keep modifying this total because total is not a final instance variable, okay? But the increment is final, it's a constant. And there is a toString method. toString just returns a string representation of this object. I say that, okay? String class has a method named format. What kind of method is that format? What kind of method? It's a static or not static? It has to be static, right? Why? Because I am calling on the class name. It's a static method, and it looks like it is printf. So actually, this is like, it's very much like a C function. What kind of function is this? What kind of C function? What kind of C function is this? As printf, right? Remember as printf? Really? You forget your old friends all the time? You didn't like as printf? It was a very nice function. As printf? String printf? You give a string and you define your format and you give other parameters. It makes a string out of these parameters and puts it in there. It's like that. String printf. Okay? Don't forget about that function. That was a very nice function. So this is like as printf. It makes a string out of this one. Total equal to something. Right? toString method. This is a very special function actually. Java knows about this. I did not invent it. Java knows about it, and we will talk about that later after I talk about inheritance. Okay, so let's write another class, increment test. Main is in it in this one. So I make a new object with increment value of 5. So I initialize my final instance, final field, okay? It's called a static final field increment. Its value is 5. And every time I call this add increment to total, it increases that total value by 5. So after that, I print that. Oh, wow. Look at this one. So interesting. Look at this printf. It prints a decimal integer and it prints a string. But value is not a string. What's going on? Okay. Did you understand it? Value is not a string. Well, obviously, since there is no operator overloading in Java, we don't have stream insertion and extraction operators. How do we print the objects like that? Well, Java says that every object, every class should have a toString method. Okay? If you don't define it, I am going to define it one for you. Okay? So remember my favorite Java class? Class B. Okay? This class has a toString method defined in it. Okay, this class has a toString method defined in it, and if you don't define it, if you don't redefine it yourself, okay, it will print some. It will return something for you. So the toString is like that. It converts this object to a string, okay, and that's automatic. So Java knows how to, okay, Java knows how to convert this object, which is increment, right, to a string. It will call this toString method, and it will print it out. Okay? So that's how you do maybe stream insertion operator thing in Java. Okay? That's it. So how many other methods are defined for my favorite Java class? Well, I told you one of them. One of them is toString. One of them is toString. The other one is finalize. If you don't define your finalize, there is a finalize method defined for it. And what else? Well, there are a few other things to do to look at those. I need to go into inheritance. And inheritance is this. Well, it is valid, and we can use inheritance, one of the basic principles of object-oriented programming. But here's a surprise for you, okay? Surprise of the week or the day or whatever. Maybe the semester, okay? All the Java classes has to derive from this class object. There is a class object in Java, okay? Its name is object, and all the classes has to derive from it, okay? And this class object defines finalize toString in it. Also, it defines clone method, which is used to take copies of objects. Equals method, which is used to compare two objects. Okay. This, what else? Get class is like, remember the class ID function that we used in C++? It returns the class ID, and we ask what is your name and etc. It corresponds to that one. This notify all, and wait is used for locking of the objects for the parallel programming multi-threaded programs. I don't think that I will talk about them. Hash code has something to do with equals. Okay, so since all of my classes has to be derived, by the way, in Java we don't call it derivation, we call it extension. We extend classes from other classes, okay? since we extend classes definitely from this class object. My favorite class, here it is. My favorite class, well, let me make it Java class. My favorite Java class, B, okay, automatically inherits all of these methods. ToString is one of them, okay? Doesn't matter how empty your class is, it defines a ToString method. It's not that meaningful. You know what ToString does? It prints the location of this object in my Java virtual memory. What does equals do? Equals compares two objects with respect to their memory position, not their contents. And clone just clones all the data members inside an object. Finalize, you know what it does, okay? Okay, so this is much more compact way of saying what kind of things are available for a Java class like this. For a C++ class like this, okay, you have to memorize stuff, right? You have to know that there is a copy constructor going on, assignment operator, destructor, move constructor, move assignment, and etc. These are available for this class. But in Java, you don't memorize them. You look at the documentation. You only memorize that this one extends from class object. And there is no way that you can prevent this. Okay, there is no way that you can prevent this. Okay, I think I'm going to stop at this point. Tomorrow we will continue about our inheritance. And after the inheritance and polymorphism, there is not much going on with the object-oriented programming, right? You know how to write classes, you know the meaning of the encapsulation, you know how to do the encapsulation. You are going to see how we do the inheritance and the polymorphism. Abstraction is already there. So by the end of tomorrow, you know how to use the basics of object-oriented programming languages using the Java language itself. Okay? Good. Okay, see you tomorrow morning.